Hello guys, so today we're going to be doing two-sum, and it says given an integer array of nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, so you don't have to worry about having multiple solutions, and you may not use the same element twice, so you can't use the same indexes basically. And you can see that we have a list of 2, 7, 11, and 15, and it has a target of 9. So it's looking for two values that add up to the target, which is, in this case, 2 plus 7. And it returns the indices. So I'm going to show you guys two methods to go with it. One of them being a brute force way, and another being a more linear solution, because it's O of n. This solution that I'm about to show you guys is n squared, which is a brute force solution, like I said, so I wouldn't recommend going with this. But basically, to find the target 9, right, you would basically check for every combination of its current index. So like, for instance, 2. You're going to loop through this and then have another loop to go check for each combination. So like 2 plus 7, 2 plus 11, 2 plus 15. Does that add up to the target? And this solution actually does work, and it will get accepted into Leetcode. But generally in an interview, you want to have like a more better time complexity, like more efficient approach for this. I'm about to show you guys O of n solution, which is using a hash map. So basically, we have a hash map, right? So on the hash map, you're going to have values on the left side and the index. Right. And you have this list right here, 2, 7, 11, and 15. And the target is 9. Basically, there's a trick to solving this problem is to just find the difference. And the difference between 9 minus whatever the value inside the list is will help you find the solution to this. So like, for instance, 9 minus 2 equals 7. And basically, you just check is 7 inside the hash map. And 7 is inside the hash map. So you're just going to add the current index into the current index's value into the hash map. So in this case, it will be 2, right? And at index 0. So we haven't found the solution yet. So this is the first iteration. The second iteration is actually going to solve the problem. This is a pretty bad example to showcase this, but it will be 9 minus 7 is 9 minus 7, which is 2 inside the hash map. And look at it over here. It is inside the hash map. So all you have to do is just return the indices. So which is I in the hash map. In this case, let's say our variable is called diff. Right. That's all you just have to return. And then that's pretty much the solution, honestly. I'm about to code it up for you guys. So hash map equals this. So we're initializing a hash map, which is this table that we're making right here. And we're going to use this function called enumerate, which is a Python function where you can use both the index and also the current index's value at the same time. So like you can do for I val. This value is the current index's value. So for I val and enumerate nums, right? So you can calculate the difference. Like I said, the difference is the target minus nums of I. Nums of I in this case is the current index's value. But like I said, we're using enumerate, so it will be target minus val. So like 9 minus 2 in this case. Right. Okay. So now you can do if diff in hash map. This is where you can just return the pair, which is I and the hash map of diff. It doesn't matter what order you get because the solution will still be the same. But yeah. Else, sorry, not sure why. There we go. Okay. Else, you can just take the current value and add it onto the hash map. So this is how we're gonna add the values onto the hash map. So like you saw how earlier 9 minus 2 equals 7. 7 is inside the hash map, so we want to push the current value inside the hash map. So you're gonna do hash map of n, hash map of val equal to I. So it's pushing the current value into the index. So 2 is the value and I is the index, right? And that's all you have to really submit. You don't have to return anything, but I can just do it right here and it should still work. Oh, unindented. Looks like there's an indented. Yeah, if I'm not mistaken. Oh, it looks like there's more unindented. Sorry about that. Let me fix the indentation. Just make sure everything's correct. Yeah, as you can see, this solution is very efficient compared to like just using 2 for loops. So yeah, and you don't even need to return anything. And out here, I'll just submit it. Okay, now the time complexity of this. Yeah, it beats 81.36%. It's a very efficient solution. So the time complexity of this, right? Earlier, the time complexity of like the 2 for loops is n squared, right? But this one is O of n. Because you only gotta, it's only one pass. It's a one pass solution. You only gotta go through it once. But the space complexity is also O of n. And that's because potentially the whole input of nums could also be inside the hash map. But that won't happen in all test cases. So yeah. But thank you so much, guys. That'll be it.